Okay, you guys, this video is a little bit more Lewis structure. It is kind of an advanced Lewis structure. So I skipped the resonance slides in your notes. We're going to come back to those on Friday, but I want to give some visuals with that. So we're just going to keep going with the basic Lewis structures. So with covalent compounds, oftentimes there's multiple central atoms. So what that means is that it's not just going to be one atom with a bunch of things around it. So oftentimes when we write compounds, the formula can give kind of some clues about the arrangement. So these two compounds are the same. This one doesn't give us as much information, but this one kind of chunks it. So the CH3 is going to be carbon with 3 hydrogens around it. Then CH2 comes next. Then the OH comes. So like I said, sometimes with organic compounds like this, it breaks it up. So either way to write it is correct. That second one just gives you a little bit more idea about where things go. Oftentimes the carbons are going to be connected in a carbon chain. The oxygen is usually kind of off of one of the carbons, the end carbon, and then the hydrogen are kind of spread evenly around. As always, feel free to kind of Google if you need to double check a structure. If you're not given that clue, put that least electronegative in the middle, and then kind of equally place the other atoms around that central atom. It'll be kind of you'll have to play with it a little bit. Okay, so let's draw the Lewis structure. I already kind of did, but let's put the electrons in. So first step is going to be to count up the total valence electrons. So we've got 4, 3 plus 4 plus 2 plus 6 plus 1. So 7, 8, 9, 10, 11, 12, 13, 19, 20 total. Okay. So again, when we're broken up into chunks like this, it gives us a really good idea of what we should do. So we'll start with the carbon, give it its 3 hydrogen, put in the next carbon with its 2 hydrogen, and then we'll put the OH last. So we've used 2, 4, 6, 8, 10, 12, 14, 16 electrons in those 8 bonds. So we've got 4 left. So we're going to put them on on the most electronegative. So between carbon, hydrogen, and oxygen, oxygen is the farthest to the right. So it is the most electronegative. So let's just double check that everyone's happy here. We'll assign formal charges. So carbon came with 4, and it still has 4 things around it. So its formal charge is 0. This middle carbon came with 4, and it has 4. That's 0. Oxygen came with 6, and it's got 2, 4, 5, 6. And then each hydrogen came with 1 and has 1. So those are all going to be 0. So notice I just kind of stick those formal charges into the actual drawing. Sorry, that should be a 0, not a 6. So everything's formal charges are 0. This is a good structure. Okay, let's draw the Lewis structure for C3H4. So oftentimes when we see multiple carbons, there's going to be a carbon chain. So I'm going to start by attaching those 3 carbons in the center. Actually, I need to do my count, don't I? So 4 times 3 is 12. So another 4 is 16 total. Okay. Then the hydrogens get split evenly. So when I put the hydrogen on, I'm going to put them on the end carbon. So I'm going to start by getting this one as many hydrogens as it can have. And then whatever's left, I'm going to put on the other side. So I'm going to fill one side first, and then I'll fill the other, or start to fill it. So I've got 2, 4, 6, 8, 10, 12 in my bonds. So I've got 4 electrons left. And I'm going to go ahead and put them on my carbon. I'll give them 2 to this and 2 to this since they have the same electronegativities. So when I look at filling the octet rule, because our first job is always to fill the octet rule, this carbon over here, and we'll call this carbon number 1, has 8. Carbon number 2 has 2, 4, 6. And carbon number 3 has 2, 4, 6. So I know that I'm going to need to do some sharing. I don't want to take any, or there are none to take from that first carbon. And I don't want to share with that first carbon because it already has 8. So I am going to take these electrons and drop them in. But that's only going to help my third carbon. So I also need to take these electrons and drop them in here. So when I redraw this, it is going to be carbon with 3, and then a triple bond, because there was a single bond. I dropped 2 more pairs of electrons in there. And then let's double check. So this carbon brought 4, has 4 for a formal charge of 0. This carbon brought 4, has 4. And this one brought 4, has 4 for a formal charge of 0. So this blue structure here is my best structure. Okay, so you guys, there are some exceptions to the octet rule. So remember, octet means 8 valence electrons. There are 3 types of ions or molecules that don't follow the octet rule. So if there is an odd number of electrons, there is going to be one that either has 1 too many or is not going to have enough. There are a few types of molecules like boron and hydrogen, a few types of elements that are just too small to have an octet. And then there are actually elements that can have more than 8, and we call that an expanded octet. So let's get a couple examples. So the first one is the odd number of electrons. They're pretty rare. They're super unstable. That electron doesn't like being without a partner, but it can happen. So in that case, we've got a single electron here or a single electron here, and we want to know which one is better. So we'll have to assign formal charges. That's how we decide if it's better or not. So nitrogen brings 5 valence electrons, and there's 1, 2, 3, 4, 5 things around it right now for a formal charge of 0. Oxygen brings 6, and it's got 1, 2, 3, 4, 5, 6 for a formal charge of 0. So that's actually a pretty good structure right here. Otherwise, over here, nitrogen brings 5 and has 1, 2, 3, 4, 5, 6 things. That's a -1. And oxygen brings 6, but has 1, 2, 3, 4, 5 around it. It's a +1. So nitrogen is farther to the right then, which means it's more electronegative. So if there was going to be a negative charge, it should have been on the oxygen. So this is not a viable structure. That's not a good one. Okay, the next thing that we might see is fewer than 8 electrons. So if we looked at BF3, boron has 3, each fluorine has 7 for a total of 21. So that's 24 electrons that we have to work with. So with those 24 electrons, we were able to get 3 different structures up above. But in each of those structures, the octet is full, but boron has a -1 charge. Fluorine is the most electronegative atom, which means that under no circumstances should it be a +1. It is the best at attracting electrons. So what would actually happen is boron would be totally fine having only 6 electrons around it, and each of the fluorines will have 8. And that actually gives everyone a formal charge of 0. So that's a much better representation. So this one here we call the dominant. The other structures could potentially happen for a moment as the electrons are moving around, but they're much less important. Okay, so if filling, there's kind of a rule here. So if filling the octet of the central atom results in a negative charge, and then a positive charge on those more electronegative, don't fill the octet. Okay, so that middle one, we put it in the middle because it's the least electronegative. It should never have a -1 charge. If it does, you have maybe gone too far with your double bonds or your triple bonds. Okay. The second option is having more than 8 electrons. This only happens for elements that are in the 3rd energy level or below, and it has to do with that 4s 3d electrons. So remember when we were doing our electron configurations, we filled the 4s and then went back to the 3d. So if we are at a point where we haven't filled up that 3d yet, there's kind of some empty space in the atom that we can fill. And that's where we're going to get that overfilled octet. So when we look at PCl5, phosphorus has 5, chlorine has 7 apiece. So 7 times 5 is 35 for a total of 40 electrons. The only way that you can have phosphorus, which is our least electronegative in the center, and 5 chlorines is if you, or fluorine, sorry, is if you, this should F be F5, is if you put those 5 fluorines around it. But at that point, now you've got 2, 4, 6, 8, 10 electrons around our phosphorus. Phosphorus is one of those atoms that is totally okay with that. So when we look at this form, fluorines each brought 7 and have 7. So each of these fluorines have a formal charge of 0. And the phosphorus brought 5 and has 5. So it also has a formal charge of 0. So this is a completely stable structure. Another situation might be with ions. So if we look at the phosphate ion, which is PO4 3-, we can draw the Lewis structure for the phosphate ion with just the 8 electrons around it. But that is going to put a lot of charge on this. So we've got -1 out here on all of our oxygens, a +1 in the center, and that is pretty unstable. So instead of doing that, if we drop in one of these double bonds, we can resolve one of that outer negatives and one of the inner positives. This one here, the second structure, is much better. So again, you guys, these Lewis structures take a little bit of playing around. We're going to work on it more over break, but I want you to get kind of a general understanding of the rules. Again, that eliminates the charge. You're also going to find that with this rule of being able to have more than 8 electrons, noble gases actually do participate in some bonding, and they have really large expanded octets, like 16 electrons. So we will look more at this. You guys should be able to complete that first Lewis structure worksheet, and we'll dig into more detail on Friday with it.